this is my intention, that we will look at this NoSQL movement. The textbook says NoSQL movement, right? So let's not change that thing. We will first look into it. That's precisely what I'll do today. We'll look at this thing, like why is NoSQL too popular these days, right? Why people or the industry is moving towards NoSQL databases. And we will see, we'll understand what do we mean by NoSQL, all right? And what is this NoSQL all about? And then we will look into this type of, this concept rather I should say, which is the key value stores. And then we will look at the other types of NoSQL databases, okay? So now let's start with the NoSQL movement, right? Why was there a need to develop the NoSQL databases, right? Why was relational database not sufficient to deal with all the kinds of data that we have, right? So if you look at the applications or whatever you use, whether it is Facebook, whether it is Amazon or any other favorite app that you're using, probably most of those are storing their data not in relational format, right? They have gone beyond the relational database, right? So now let's try to understand why was there a need of NoSQL databases. So you know, the first thing that we have in favor of NoSQL, which goes against the RDBMS, relational database management system, that we discussed throughout the semester, is sometimes the strength becomes a weakness, right? So let me phrase it like that. So the RDBMS, right, they have this ACID criteria. So let me summarize. The strength of the relational database, which is ACID requirement, becomes a bottleneck when we are dealing with huge volume of data, right? Much larger data, and so much so that the data is also not structured. In relational databases, we want a structured data, right? Do we understand what is structure? Schema, right? Structure is determined when you declare your table. You say, okay, you know, this table is going to have these many columns, and this kind of data will be storing in each column, and then we define so many constraints, right? We define the primary key constraint, we define the domain constraint, integrity constraint, and all that. And the data that you put in the table has to conform to those constraints. If not, then the database is no more consistent, right? So consistency is very important in relational databases, right? Which becomes a bottleneck when we have to handle huge volume of data, and the data which is not structured or unstructured, semi-structured, right? So that's the point. RDBMS puts a lot of emphasis on keeping data consistent. Now the entire database it should be consistent all the times. That's the requirement of relational databases, right? And for that, the relational database came up with the concept of ACID requirement for any transaction, right? So what is a transaction? All those things we discussed is a database application which follows the ACID requirements. Now, because of this ACID requirement, which boils down to consistency, as I'm saying, that's the reason I was, okay, so let me make it simpler. We have the constraints, right? So the database would be consistent as long as it follows all the constraints, right? Primary key constraint, domain constraint, referential integrity constraints, and check constraints and all, which are semantic constraints and all, right? So there's so many constraints that we have, and the database should always follow that, which is a big bottleneck. So the focus is on consistency, and that consistency focus may hamper the flexibility and scalability. Guys, well, as I could understand, the two main requirements of NoSQL database or the movement has been the flexibility and scalability. Scalability is the most important thing along with the flexibility. So consistency doesn't allow that, and consistency is one of the one of the criteria of ACID. Now, as the data volume and the number of parallel transactions increased. Now, for that to handle the capacity of the system that is dealing with this data should increase as well, right? So in very simple terms, assume that you have a relational database, right, that is handling, say, I'm trying to come up with an example which is realistic. Let's assume that the system that we have, which is using relational database, is handling 100 transactions per second, right? A smaller number only. And if it changes a lot, right, so to say millions of transactions per second, something like that. Now, what we will have to do now, we need to make our database more efficient, right? We'll have to add the capacity to this. This system that we have, the DBMS that we have, should be able to handle a lot of parallel transactions, right? And for that, we need to make it more efficient. Now, let's look at the possibilities. So that boils down to some technical stuff, right, which we'll try to understand. Scaling. Scaling means how can we increase the capacity, right? So let's try to understand what these terms are. Vertical scaling. And vertical scaling is something that you will try to achieve for relational databases, right? Because that is simpler to do. Now, what do we mean by vertical scaling? In vertical scaling, you have the same system which you are making more efficient by adding more processing and more storage capability. The same server, right? Let me make it a lot easier. Let's think about our database, which is relational, stored in single server, right? So it has a processor. Let's assume the processor is decent enough, and it has the storage capacity. Let's assume that that is also decent enough. But the problem is that for some reason we are over flooded by the requirement, right? Too much data is coming to us, and too many transactions we have to handle. Now, in vertical scaling, what we will do, we will come up with even more powerful CPU, right? Could be, I'm just thinking about it, right? Maybe supercomputer. I don't know whether supercomputers are still used, but it's one CPU, extremely powerful. That's what we are doing, adding more computation power to the CPU. And at the same time, we are increasing the storage capacity also. But that thing is happening at one server only. We have only one server, and that server is being made more and more efficient. This is called vertical scaling. Now we have the other option possible, that is called horizontal scaling. And horizontal scaling is even more interesting. In horizontal scaling, what we do, we will have multiple servers, right? And probably these servers are arranged in a cluster, right? And all these servers, they are working together to handle this data need, right? It's just like this, assume that there is a project, right, which I'm handling. I'm handling, or person X is handling. Person X is smart enough. So what happened? The demand of the project, increased. So what this person X started doing, rather than spending, say, 8 hours per day or say 10 hours per day, now this guy is spending what? 12 hours, 13 hours, 15 hours, right? Is not sleeping enough few days. But is that achievable? At some point, this guy will burn out, right? This solution versus, in place of one person, this guy has 2 more people or 3 more people, right? And all these people working together. Now you can imagine which one is going to be more efficient, right? So same is the scenario here. In NoSQL kind of a system, or I should say in present system, where our data need is so intense, right? The transaction that an app may have to handle is so intense that probably this vertical scaling is not going to happen, right? So this is where the NoSQL movement is very, very convenient in horizontal scaling. In horizontal scaling, in place of having just single DBMS server, you will have multiple DBMS server, and these servers will be connected together in a distributed manner, okay? Maybe in the form of a cluster. All right, so that was one point. Now, Another point which is in favor of NoSQL movement is again a drawback of relational database management system, that is to horizontal scaling. Now, there is a limit to vertical scaling, right? I tried to explain that with the help of a smart person who tries to handle the whole project, right? So much so that this guy is not even sleeping, right? Spending all the time working on the project. There's a limit. This guy may burn out in 3 or 4 days maximum. So similarly, for relational database also, their extension to horizontal scaling is not good, right? When it comes to distributed system, they don't do well. Because, with relational database management system, as I said, its strength is ACID, right? The requirement for a transaction. Now, it gets very difficult to achieve when you have distributed framework. So, coordination overhead becomes extremely difficult when you want consistency. You want consistency, but you want to do it in the horizontal way, right? Having the servers spread across the cluster. There it will get very difficult because relational DBMS, they are based on very rigid schema, right? So that doesn't scale well in the distributed framework. Now, the requirement that we have is that we will have massive volumes of data, and the data might be flexible in structure. And for this massive volume and flexible data requirement, this would ask for scalability, which is not possible in case of relational databases, right? So again, in plain and simple words, the strength of the relational DBMS, which is its rigid schema requirement, and the ACID becomes a bottleneck when we need to deal with huge volume of data that would also need the scalability, right? So the other types of DBMS, which are called as which we'll consider in NoSQL category, they will be massive in volume, and their structure would be flexible. In that case, we would need scalability and availability. So what will happen? That will happen in the next class. I'll come up with a framework that is supported by NoSQL, which is interestingly called, RDBMS has ACID, right? NoSQL has a base. Maybe in chemistry you learned about acid and base, right? So what these smart people have done, they have come up with the term base, right? For relational database we have ACID, for NoSQL we have base, right? So E is for eventual consistency, I think. S could be for scalability, A is for availability, B is for something, right? So, well, we will go to that later, but here what we need to consider in this bullet is the fact that in NoSQL databases, the emphasis is more on scalability, flexible database, flexible data structure, sorry, and the availability. So A is for availability over here. Now, we can look into the flexible data structure. In a relational database, what is the data structure that we use? I'm happy with that, right? Table is the data structure, right? That's how we store the whole data. Whether it is the data about an entity or a relationship, it goes in some table. But the tabular, the storage of the data in tabular format may not work in a lot of cases, right? That's something we will figure out very soon. So yeah, that resulted in the movement, NoSQL movement, or the emphasis above on NoSQL databases. Now, what do people think about NoSQL? Why is it called NoSQL? What is this no here? Does that mean that we will not use SQL at all? Not only SQL, right? Very good. That is the interpretation of NoSQL. It's not that we are saying no to SQL. For some reason, all these different kind of databases that we'll learn in this lecture slide, they are not relational in nature, right? But that doesn't mean that they will not. They are saying, okay, let's say no to SQL. right? So they may still have some query language that would resemble SQL. But anyway, in NoSQL databases, we will learn about the databases where they will store and manipulate the data in other format than the tabular relations, right? So more appropriate word for NoSQL databases would be to call them REL, non-relational. We are storing the data not in table but in some other format. Okay, so a better term would be to call them no-rel in place of NoSQL. Anyway, so now one of the strength or the motivation behind the NoSQL databases is to attain a linear horizontal scalability, right? If you need more processing, what we will do, we'll add more servers, right? So as simple as that. Because adding servers is not a problem, right? You need to probably increase the size of your cluster. Easily achievable than making, than trying to achieve vertical scaling, right? So NoSQL databases, they aim at linear horizontal scalability by distributing data over cluster of database nodes for the sake of performance as well as availability. So this performance and availability would be clear soon, right? But yeah, with NoSQL it is easily done, right? Add more nodes to the cluster, and horizontal scalability is not a problem. That has to do with the way we store the data, right? It's not a table. If it was a table, that will be probably the end of the story. Now, one interesting thing about NoSQL databases is that we don't try to achieve the instant consistency. In ACID, the consistency that we need is instant. All the time, the database should be in the consistent state. But in case of NoSQL, we have some relaxation. We want the consistency, but that is eventual consistency, not continuous consistency. Eventually, the database should be in consistent state. So the data and all its replica will become consistent at some time after each transaction, right? But this was very strict in case of relational databases. Okay, so what I'll do, let me take you to this slide, probably the last slide for it, and see how the relational database is different from NoSQL database. So data paradigm, right? Like the data is stored in relational tables in relational databases, whereas in NoSQL databases we have so many options, right? Key value, document based, column based, graph based, object based. And in case of the distributions, for relational, data is mostly in a single node or could be distributed, whereas in NoSQL it is mainly distributed. Scalability, if you want to have scalability in relational database, you should go with the vertical scaling, which is harder to scale, right? It is harder to scale horizontally, whereas vertical scalability would be a possibility, but that has a limitation. We can't go beyond a limit. Whereas for NoSQL databases, it is easy to scale horizontally. Easy data replication, openness. Well, for relational, you can have the closed version versus open source. That is about, in what form you can get. So some relational databases you'll have to buy, like Oracle, whereas for other, like NoSQL, it is open source. For NoSQL, these are all mainly open source.